In this lesson, we'll be discussing the effects of transformations. By the end of the lesson, you should be able to identify the properties of a reflection, rotation, and translation, and decide which properties of the original figure are preserved and which are changed. You should also be able to dilate a figure and determine the effect on perimeter and area. So properties for reflections, rotations, and translations. The pre-image and image have congruent sides, their angles are equal, and the perimeter and area stay exactly the same. For dilations, the pre-image and image, the angles are equal, the sides you multiply by the scale factor, the perimeter is multiplied by the scale factor, and with area, it's multiplied by the scale factor squared. So the perimeter, you find the perimeter of your pre-image, which is 2 times length times width plus width, or length plus width plus length plus width, and you just multiply it by the scale factor. With area, to find the pre-image, we take length times width, and then you multiply that by the scale factor squared. So if the scale factor is 3, we would multiply it by 9. If the scale factor was 4, we'd multiply it by 16. So for example, Grandma wants to enlarge the family photo to poster size, which is 3 times larger than the picture she has. How will this affect the angles, side lengths, perimeter, and area? So in this one, there's not going to be any change to the angles. It's being dilated. The side lengths will be 3 times longer. So this side was 10, now it will be 30. This side was 8, now it'll be 24. The perimeter, the original perimeter is 36 inches, so that would be 3 times larger, so now it would be 108 inches. And the area is now 80 inches, so that will be 9 times larger, which is 720 inches squared. Samuel bought a poster to hang in his room, but it's too big. He needs to buy one that's half the size. How will this affect the angles, side lengths, perimeter, and area? Again, the angles stay exactly the same. The side lengths are half the size, so this was 20, now it'll be 10. This was 16, now it'll be 8. The perimeter was 72 inches, so it's going to be half that at 36 inches. And the area was 320, so it will be 1/4 the size, because 1/2 squared is 1/4, and it will be 80 inches squared. So if the scale factor is 2, the angles don't change, the side lengths are 2 times larger, the perimeter is 2 times larger, the area is 4 times larger. If the scale factor is 3, the angles don't change, the side length is 3 times larger, the perimeter is 3 times larger, the area is 9 times larger, 3 squared. If the scale factor is 4, the angles don't change, the side length is 4 times larger, the perimeter is 4 times larger, the area is 16 times larger. Now let's say it's a reduction. The scale factor is 1/2. The angles don't change. The side length is half the size, the perimeter is half, the area is 1/4. 1/2 times 1/2 is 1/4. Let's use a scale factor of 1/3. The angles don't change. The side length is 1/3 smaller, the perimeter is 1/3 smaller, and the area is multiplied by 1/9, because 1/3 times 1/3 is 1/9. Scale factor of 1/4. Angles don't change. The side lengths are 1/4 times smaller, the perimeter 1/4 times smaller, the area 1/16 times smaller. So how does dilation affect the perimeter? We just multiply it by the scale factor. How does dilation affect the area? It's the scale factor squared.